Are you able to see the screen?
Yes.
Okay. So Bismillah ar-Rahman ar-Rahim. For the last two lectures this week, we have been talking about the principles of class design, and we have gone through what we call solid principles, four of them. The number one was the single responsibility principle. That whole idea was that each class should be responsible for, or there should be only one reason for changing that specific class. Open close principle was also discussed, where basically we say that we are open for extension but closed for changes. And the scope substitution principle was all about inheritance, that we should not be changing the characteristics of the methods, and in other words, the objects of the children can replace the objects of the parent without really breaking the application. And the interface segregation principle was there, that we should not have fat interfaces. In fact, we should have segregated interfaces. Now, the last one we're going to talk about, which is the last of the solid principles, which is the dependency inversion principle. So inshallah, we're going to talk about this today and now, and this will help us complete the discussion on these solid principles. Okay, so what's the dependency inversion principle? The idea behind dependency inversion principle is that you want to somehow avoid the tight coupling between the classes. And the reason is, if you're going to have these tight coupling, then what we mean by ease of breaking the application is basically because you will have to, if you have to make a change, you will have to make a change in so many different places, and that's a problem itself. So the idea behind dependency inversion principle is that basically you avoid tightly coupled classes and source code. In other words, what we want to do is we want to have high-level modules, in other words, should not be depending on low-level modules. Rather, we want these two modules to depend on an abstraction. So in other words, we don't want high-level modules or high-level classes depend on the low-level classes. In fact, we want both of them to depend on an abstraction, like an interface or an abstract class. And of course, this is just a byproduct of it, is that abstraction should not depend on details. Details should depend on abstraction. This is just a byproduct of it. But the whole main focus of this in principle is that a set of classes which are kind of depending on each other, that we should not have these classes depending on each other directly, but rather they should depend on an abstraction. Now, of course, what is a high level and low level class here? It's very context specific. This is very specific to your application. In other words, what we really mean by this is we want to somehow decouple these high level and low level classes. This is the whole principle. High-level classes usually encapsulates complex logics, while low-level classes includes data and utilities. Again, this is specific to your application. So what's a high-level class and what's a low-level class will be specific to your application. And I'm going to show you an example very shortly. And hopefully, if you are a bit confused about what's a high-level and low-level class, I'll show you an example very shortly. But the whole idea here is that the principle says us decouple them. And decouple them and let both of them depend on a certain abstraction, like an interface. So typically, this is a common mistake we do. Most of the designers will go on and do what? They will make the high-level classes depend on the low-level classes. It will compile, it will work from a source code compilation perspective, but is it a good design? That's the whole idea. It's not a good design, and we'll see very shortly through an example that why it's not a good design. So the whole concept is let the both depend on abstractions. In other words, they say the principle says let's invert the dependency, let both of these high level and low level classes depend on abstraction. And the reason you want to do it is because when you're going to change or replace the low level classes, so for example, in other words, if you don't follow the dependency inversion principle, because of the tight coupling between these classes, if you're going to make a change in one of them, the other one will be affected as well. While if you follow the dependency inversion principle, you can avoid this problem because they will both be depending on an abstraction like an interface. So, as I said, all you have to do is basically add an abstraction layer and let both the low level classes and the high level classes depend on this abstraction rather than the concrete implementation. Uh, it's very interesting to know and observe that this dependency inversion principle actually is a very specific combination of open close and Liskov's substitution principle. So it's actually a combination of application of these two principles. How? I'll show you very shortly, inshallah. So let's look at an example and let's try to understand this principle with the help of an example, and probably inshallah it will become more clear, and then we'll open the floor for questions to talk about what it really means and how open close or Liskov substitution principle is being applied on it. But in a nutshell, this principle says, right, they don't have concrete, don't let's not have hard coded dependencies, but rather introduce an abstraction there. So let's use the same example we have been using throughout these solid principles. Bookstoring one, and for us to help understand this one, the idea is that the customers of the bookstore shop or the system comes and says to us, we want our customers to be able to put their favorite books on a virtual shelf, right? So we said, okay, no problem, and what we can do is basically we can implement this functionality of being able to add a book to a shelf is by having a low level class called book class, and we're going to have a high level class called shelf class. This that we say, okay, we have a book class, and we can see the reviews and we can read the samples, and then we have a shelf, and here we can basically go on and add books to the shelf. So far so good?
Yes.
Okay, so
Doctor, we can't hear you. You are muted.
sorry. So basically, in this book class, we can add, the users can go and see the reviews and they can read the samples, right? And of course,
Doctor, you are muted.
somehow it's getting mute all again and again. Let me say this everything again. I don't know what's happening here. Did you guys get this one?
Yes.
Of course, we're still going through the example, but did you hear me when I was talking about these ones?
No, we didn't hear you because you
Okay.
were muted.
I was muting, right? That's what I was trying to say. Okay, so basically what we're saying here, let me come back from here. Okay, uh, so we have this bookstore, right? And they want us to add a new functionality. Okay, and the functionality is that the customers should be able to add their books to a virtual shelf. So what we will be doing is basically we'll be creating two classes. One is for the books and one is the shelves. Books, basically you can go on and see the reviews and read the sample chapters, while in the shelf class, we can go on and add the books, right? So far so good?
Yes.
Okay. Now, which one is the high level class, which was the low level class in this specific example?
I think low level is the book class and the high level is shelf, I think.
Correct. Absolutely. And why you think that book is a low level and shelf is a high level? What's the reason behind it?
because the book is specified for something, okay, and the shelf is not specified, I think.
Yeah,
That
shelf
makes
is
it for
basically, yeah, shelf is basically allowing you to add books. So in other words, if you don't have a book, you cannot have shelves in a sense, right? Correct?
yes,
Right?
yeah.
Or your shelves will be empty in a sense, right? So I did implement this one, you know, will it compile? And will it serve the purpose of the customer, which says that a customer should be able to go on and add books to a virtual shelf? Will it satisfy the requirements of the customer?
I think yes, it will satisfy
Exactly. It will
satisfy it.
satisfy,
Yeah.
it will compile, it will work. So no problem from that perspective, right? Everything looks fine, right? Uh, but the only thing is that this specific, the way we have written this code, this specific organization is violating the dependency inversion principle. And the reason is in violating is because the the high level class is now depending on the low level class, right? And this is what exactly the dependency inversion principle says, that decouple them. Let's not have high level classes depend on the low level classes. This is why I said that most of us usually do this. We say that, well, do it, and because it will combine and it will work and it will do the job. But actually it violates dependency inversion principle. And the reason is because, say, tomorrow down the track, the customer says, we want to now add DVDs, right? So we want the customers to be able to add DVDs to their shelves as well. So what we will have to do now?
We will have another one, like one-to-one with the DVDs, and if there another thing, we will add that item to the shelf. So we will
Exactly.
keep adding.
Exactly. So basically, we'll have to create a DVD here, right, where we can see the reviews and watch samples. And then, we'll have to go on and modify the shelf class, right? So we'll have to come here and add DVD or something like this, isn't it? Now, since this is going to happen, does it violate open close principle?
It does.
Exactly. Because the open close principle was all about, yes, we're open for extension, but we're closed for modification. So in this case, I'll have to go and modify the shelf every time, as you said. Every time we have to add a new types of a item like DVD, and tomorrow down the track, who knows, something else, magazines and stuff like that. We'll have to come back and keep changing this one. So it violates the dependency inversion principle, and as I said, it's a special combination of violation of open close principle and Liskov substitution. It's a special combination of open close principle and Liskov substitution principle. So different setting is actually violating the open close principle as well. So the solution is very easy. All we have to do is basically go on and create an abstraction layer for these low level classes, books and DVDs. And we can do that by easily introducing a product interface. All we have to do is basically have this product interface and let these two classes implement the product. So we'll have the product, book will be implementing the product, the DVD will be implementing the product, and basically, they're going to go on and override it. It's okay, no problems at all. And now the shelf can refer to the product interface instead of its implementations, which is the books and the DVDs. So rather than shelf depending on referring to books and DVDs, it can refer to the product interface, and that's it. So we can refactor now code as we move along, and tomorrow if we have to introduce a new type of a product like a magazine or something else, we don't have to do pretty much anything on the shelf side. All we have to do is keep adding to the interface, and it will be available to the shelf, and the dependency, the decoupling has taken place. The tight coupling between the shelf and DVD or shelf and books class have has been decoupled and have been decoupled and removed with the help of this product interface. So in other words, all you have to do is basically refer to the product interface and use it. Now, I'm making a statement here. I'm saying the code also follows the Liskov's substitution principle, as the product type can be substituted with both of its types, subtypes, books and DVDs without breaking the program. Do you agree with this statement? So you can add a book, you can add a DVD, right?
Yes, I think I
Right.
agree with that. It's
Yes, yes,
correct.
it is correct. So hence, by introducing the abstraction, you have avoided a situation where you will be forced to violate the open close principle, and then at the same time by adding this you are still satisfying the Liskov substitution principle, and as a result you are satisfying the dependency inversion principle. So at the same time, you're also implementing the dependency inversion principle as you have refactored and you have decoupled. As a result, the high level class, in this case, the shelf, is no more specifically hard coded, coupled with book and DVD classes. Rather, it's just talking to an interface, and you can go on and make changes there directly. So something like this. This was the old one. This is the refactored one. Now, the floor is open for questions and discussion. Let's see if the concept is clear to everyone. Go ahead, please. No questions? I assume everybody's happy?
It was easy, I think. It wasn't
Yeah,
hard.
it
Yeah.
wasn't hard, right? Alhamdulillah. Alhamdulillah. Good, good. So as Alhamdulillah, if everybody's feeling that it was easy, that's good. Alhamdulillah. I think I feel happy that I did my job. Okay, so in a nutshell, uh, you know, we have gone through these principles, and remember, these principles will help us become better designers. If we don't follow these principles, it not necessarily means that our programs will not compile. They will still compile. Probably they will also satisfy the requirement, but they are not going to be good designs. And for us to have good designs, we have to somehow follow these principles, which means we should take care of single responsibility. We should think and consider and carefully think about open close principle, the least cost substitution principle. Where applicable, think about the interfaces, segregation of them, and follow the dependency inversion principle to help come up with good designs. Now, as I said on Tuesday as well, and I'm going to say it again here just to make sure that all of us understand this, is that implementation of these solid design principles will sure increase the overall complexity of the code base. There's no doubt about it. But it will lead to more flexible designs. Right? Can you see this and understand what I'm saying here? And appreciate as a designer that yes, the code base will increase, but it will give me a lot of flexibility.
Yes.
Right? And that's the whole idea. That's the whole idea behind these solid principles. Can I be confident here that everybody is absolutely clear about the solid principles? Some show of hands will give me a bit of confidence here.
Doctor,
Yes, Abdul Majid.
why are we going for flexibility instead of simplicity?
Okay. Now the reason is it goes back to the very fundamental idea, probably which must have been covered in detail in 215, is that requirements are not requirements are not static. They always are changing for an application, right? And as a result, for the application, for sure, over the lifetime, will go through a lot of changes. And those changes sometimes will be forced, sometimes, you will have no control whatsoever but to make those changes. Now, if these principles are not applied in your design, this means you have tightly coupled classes. This means that, for example, you are not following the Liskov substitution principle and you're adding overridden methods which are absolutely not following the characteristics of the parent classes. It will lead you to issues where it will become very hard for you to update your systems. It will also raise issues where you will have to because they are not designed in a way that they are flexible designs. You will find a lot of time you will be testing these changes, and it's all cost at the end of the day, right? Hence, we want to come up with designs as designers which are flexible, and we can go on and make changes into them, and we try to minimize the changes and impact of those changes, and of course save cost from the testing perspective and all of that stuff.
Uh-huh. Okay, thank you.
You're welcome. Anything else, guys? Any other question comes to mind? Okay, looks good, alhamdulillah. Now let's do one thing, which is let's do another activity on the Liskov substitution principle, and let's see. Hopefully we can pick an issue in the piece of code I'm going to sharing with you guys now, and we'll discuss it. So what I'm going to do now is in the teams, I'm going to create a new folder called activities, right? Are you able to go and access the file in the files of this team? And the reason I put the file there is because it has a piece of code and it doesn't fit on one screen. Are you able to see that one?
Yes, we can
Okay,
see it now.
can see it.
great. Now I want all of you to kind of do it individually now. Open it up, and if you look at it, basically it has a series of codes in it. So basically we have an abstract class called member, and then we have a lifetime members, then we have annual members, then we have inquiry members, and then we have the main method or main class, where we are basically adding them to the database. And the question is that let's assume that you add a new abstract method called make booking into your abstract class, and basically, the business rule is that a booking can be done by all except the inquiry members. So the question is, will the addition of this new abstract method will result in violation of Liskov's substitution principle? So go for it, guys. It's available in the files, and let's try and understand and answer this question individually. Let's take a few minutes here, then we'll come back and discuss this together. Everybody is able to access the file, correct?
Yes.
Go for it,
It's really
guys.
able to.
Great. Go for it. Okay, are we able to to get the issue and have a look at what's happening? Do we have an answer?
Could you please give us more time, like
Okay,
5 minutes?
okay, okay. Okay, so let's have the discussion on this now, right? I'm sure someone. Yes, Yes, Abdullah.
Yes, Doctor. I found a solution, but I'm not sure if it's correct or not. Can I
Okay.
share my solution?
Yes, share the solution. Yes, go for it.
So the solution I thought of is to have a member abstract class.
Mm-hmm.
Okay. And then in this member abstract class, we're going to have the shared methods that are going to
Mm.
be shared between the leaves, the top children.
Yes,
Okay.
yes.
And then below the member, I'll have two also abstract classes.
Mm-hmm.
And then I will call them subscribed member and non-subscribed member.
Mm-hmm.
And in subscribed, I'll have the method which is make booking.
Yes.
And in non-subscribed, I will currently I will not have any special methods for the inquiry
Mm-hmm.
because the add to database will be in the member at the top.
Yes.
And that's it. I will implement lifetime and annual under subscribed,
Yes.
inquiry under non-subscribed.
Correct. Yes. Yes. Uh, of course, someone else can come up with a different solution. Absolutely. But are we all absolutely clear that why we need to come up with this solution? Because we are breaking the Liskov substitution principle, right? How we are breaking the Liskov substitution principle? See, this is the abstract class, right? The member abstract class. Originally, we only had add to database, correct? Now we are adding make booking. So how I'm gonna go on and break? So basically, in the original one, if you see the original one, in the original one, we are adding to the database, correct? Everybody's on board with me on this?
Yes.
Yes.
Yeah. So originally we were adding something to the database. Now we added, so we refactored this class, the abstract class, and we added this make booking. And now I'm saying, I'll just go on and change into the main class and call C make booking. Will it work or not? I mean, from a Liskov substitution principle. Are we breaking the Liskov substitution principle or not? Will it compile?
Yes, it will combine.
Exactly. So it will compile, but will it give us the right behavior for all the members?
No.
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 So what's the problem? What's the problem with the Liskovs here? So, or how we are violating the Liskov substitution principle here?
Because in query, we have to implement this method.
Correct.
But he doesn't want it in inquiry, so we will leave it empty.
Exactly. And this means what? That you have a make booking method for inquiry, which is actually not making booking, right? And hence we are changing the characteristics of that method, which is of course clear violation of Liskov substitution principle. Everybody understands the reason we are breaking the Liskov substitution principle here?
Can you repeat, please?
Yes, yes. So Saud, what we're saying here is that in the original piece of code, here we were adding them to the database, and of course, all three members were supposed to be added to the database. Now we went on and we changed our abstract class and added a new method called make, abstract method called make booking. Now, since we have make booking, of course, all the classes which are implementing this abstract class has to go on and implement it. Now, in other words, when I'm going to come here and I'm going to try and add, make booking, it's a valid thing, for lifetime members to make booking, annual members to make booking, but for inquiry, as per our new requirement, they should not be able to make bookings. So what this will be doing is that we will have a make booking method for inquiry, which is basically dummy. It's not doing anything. So in other words, it's actually the implementation of the make booking for inquiry class is actually not making booking, which is a violation in a sense, because now you're changing the characteristics of making booking method, which was being inherited from your parent class. Is this clear?
Okay. Yes, I get it now.
Yeah, so um, basically we should not be yes, no, we are allowed to override. Let's not be confused here. We are allowed to override, but we should not, if it's make booking, that still should be make booking. So for example, you can go on and override it for annual members and give them some kind of a discount, or lifetime members you can give them some kind of a discount, but still it should be making booking. While in case of this inquiry, it will will be writing a make method which is basically not making a booking at all, and which is absolutely against the Liskov substitution principle. And of course, the solution or how to improve it, Abdullah gave a very nice one where we add basically 2 layers of abstractions to come up and come up with a subscription based and non-subscribed members, and then you can you'll have a better flexible one.
Doctor,
Yes.
can we have a solution like make an interface and make the interface inside it a method called make booking, and the lifetime member and annual member implement this interface? Is it okay or what?
It's okay as long as as long as we do not violate, for example, the open close principle, and we don't violate the dependency inversion principle. Of course, the moment you will be introducing the interfaces, you're not probably going to be violating the dependency. Yeah, why not? Yeah, the solutions are either with the help of these abstractions, definitely. Okay, so alhamdulillah, I think everybody is comfortable with this. This was the whole idea of this activity. So now, alhamdulillah, we're done with the solid principles. So now what I'm gonna do is I'm gonna just give you a bit of an idea about An idea about the design patterns, of course, will not be covering them in detail today. I'm just going to start and just give you a basic information about it, and then inshallah ta'ala on Sunday onwards we'll talk about design patterns. So but before I talk about design patterns and what exactly are they, why I'm not getting the interesting. Okay, I think I solved the problem. Are you able to see the screen?
Yes, we can see it now.
Okay. Now, but before I talk about design pattern and what exactly they are, let me refresh us with a diagram I showed you just before we start talking about architectures. Remember that diagram where we talked about, we have design patterns at this level, and then you have some, architectural styles, and then we had what we call domain specific architectures. Remember that diagram? And then,
Yes.
on the y-axis, you need to have, detailed domain knowledge and minimal domain knowledge in a sense. And this was all about, level or scope of the of the structure. Like this was programming languages specific or close to programming. This was more to do with the structure and so on and so forth, right? Remember that diagram? So here now, after alhamdulillah, our journey at the end of week 9, we are here now. So we're going to talk about, so we already know the architectural styles now. And we also know some of the, basically we know the package design and class design principles now. So we're going to now look at design patterns. And over the next 2 weeks, probably we'll talk about these design patterns and we'll try to understand exactly what they are. And actually, of course, we are getting closer and closer to the source code now as well, right? So we're going to look at these design patterns and see how we can better organize our class diagrams or part of class diagrams to achieve certain good design principles or properties. So the whole idea is, and I'm pretty sure after looking at the package diagram pattern principles and solid principles, we know this now, right? That there are designers and then there are good designers, correct? That you can come up with a solution or you can come up with a piece of code or come up with a design and subsequently a piece of code which satisfies the requirements of the system, and it will compile and it will work, but probably there may not be a good design because it's not flexible. It's very difficult to change, a lot of coupling between them, a lot of dependencies between them, and as a result, making changes are hard and so on and so forth. So there is something called designer, and then there is something called good designer, right? So whole idea of 316 is that we want us to become good designers, right? And now because we know architectural styles, because we know the package principles, we know the solid principles, we are coming closer and closer to become good designers. uh, In other words, if you recall in the beginning of the semester, I talked about the concepts of abstraction, inheritance, polymorphism, and encapsulation. They are absolutely necessary. That's why I talked about them in the very first week or the first, second, or third week of the semester. But just knowing them will not make us good designers, right? Yes, we need to follow them. We need to use them because they are fundamental concepts, but just knowing them will not make us good designers. And I think it's very evident even now, while we went through different examples of the solid principle, that, yes, we're still using the concepts of abstraction. We're using the concept of inheritance and polymorphism, but we need to use them in a right way as well. Hence, for us to become good designers, we need to go beyond just knowing these 3 or 4 fundamental principles. We need to be able to use these fundamental principles in a better way. And at the end of the day, we want to become good designers who will be able to combine these concepts of inheritance, polymorphism, and encapsulation to come up with flexible, maintainable, and reusable design. And this is an ultimate aim we are trying to achieve in 316. Of course, with the help of package diagrams, with the help of solid principles, with the help of architectural styles, and inshallah, with the help of design patterns, we are getting there. So, basically we use design patterns, and again, like in architectures, when I talked about client server, when I talked about Blackboard, or event-based or P2P, we were not reinventing the wheel. Over the years, the software engineering industry has come across different. At that time, we were talking about architecture, so people have come across different architectural issues, structural issues, and they came up with solutions. Similarly, in the industry, when it comes to class diagram and structuring of them and coming up with good design in terms of flexible, maintainable, and reusable designs, people in the market, in the industry, have already faced similar problems and they have solved it. So basically, we don't have to reinvent the wheel. All we have to do is basically be aware of these design patterns and understand that, what are the properties, what are the problems they can be used to overcome with. And that's it. So we'll be going through these design patterns, inshallah, in the next couple of weeks to better understand how we can really solve these already known problems. We don't have to reinvent the wheel. In other words, just knowing the concept of abstraction, inheritance, and polymorphism does not make us good designers. We can become design gurus if we know how to use these concepts to come up with flexible, maintainable, and reusable designs. So far, so good.
Yes.
Okay, cool. Thank you. So the question is, what are design patterns, right? Now, design patterns are, this is one definition. Design patterns are combination of class combinations and certain algorithms which can help us fulfill certain common design purpose. And design patterns basically help us express an idea or a solution of organizing these classes. Another definition is that design patterns are description of communicating objects and classes that are customized to solve a general design problem in a particular context. And this is probably more easier to understand and meaningful is that there is a general design problem which is faced by all which is faced by different designers in their own systems context. And if you know these design patterns, you can just use these design patterns to overcome those problems. Okay. How will become very clear as we will go through these design patterns. So basically, I'll not be going through them today. Even we'll go one by one, but I'll not be even showing them today. But I'm just let you know, and we'll stop it here, and we'll use this as a starting point, inshallah, after the weekend. Is that you have different kind of design patterns. You have creational design patterns. You have something called structural design patterns, and then we have something called behavioral design patterns. There are many of them out there in the market. We'll be going through some samples of them, the ones which are extremely popular and useful. We'll go through them. So each category will go through some examples of these patterns, right? Now what they are, how they look like. Inshallah, we'll choose this as a starting point from Sunday onwards. Okay. So it's already almost 10:50 now. So let me stop the recording, take the attendance, and then we'll take the questions.